Hello everyone, welcome to another bright session with the educational biome of pure excellence, PDV LEADEX Education. So as you can all see on the board, we are going to be discussing about the strength of sigma and pi bonds. I'm sure you have been told that sigma bonds are stronger than pi bonds, but probably you're not given the reason why sigma bonds are actually stronger than pi bonds. Or if you have been wondering which of sigma bonds and pi bonds are stronger, right? In this lesson, we are going to explain to you which of the two is stronger and why that one is stronger than the other. But before we go ahead, please, I will invite you to press the like button, right? Press the like button, guys. Like the video because as you know, you are going to enjoy the lesson. So please press the like button right now. Share, right? Press the share button. Share this video. Repost this video, right? Please repost the video. We will be very grateful if you do that for PDV LEADEX Education. So thank you so much. Press the like button, reshare the video, and get seated. Let's demystify sigma and pi bonds. Okay, so just a little recall after our previous lesson on hybridization, we said that hybridization was a mixing of pure atomic orbitals to form molecular orbitals of the same energy or similar energy called hybrid orbitals. Hybridization had to do with atomic orbitals coming together, fusing up to produce new orbitals called hybrid orbitals, and that hybridization is a process by which covalent bonds are formed. Right? In hybridization, two types of covalent bonds are produced. We call them sigma bonds and pi bonds. Sigma bonds and pi bonds. And we earlier mentioned that sigma bonds were formed by the head-on overlap, of atomic the head-on overlap of orbitals. And those orbitals could either be pure atomic orbitals overlapping head-on, or hybrid orbitals overlapping head-on, or a hybrid orbital and an unhybridized orbital overlapping head-on. And that gave us 5 different methods by which sigma bonds are formed. First method, head-on overlap of 2 s orbitals. Second method, head-on overlap of 2 p orbitals. Third method, head-on overlap of 2 hybrid orbitals. Fourth method, head-on overlap of an s and a p orbital. And lastly, the head-on overlap of a hybrid and an atomic or an unhybridized orbital. Then the pi bond, right, is a second type of covalent bond formed through the process of hybridization. And we said that a pi bond is formed only by the lateral overlap, only by one method. And that method is what? The lateral overlap of 2 p orbitals. A p orbital overlaps laterally with another p orbital and they produce what? A pi bond. So in this lesson, we are going to draw a diagram to show how sigma and the pi bonds are formed. Okay, as we said, this is a structure of a sigma bond of an s orbital, and this is the structure of a p orbital, right? The circle, right, the ring represents the nucleus. So sigma bonds formation, the first sigma bond formed by the head-on overlap of 2 s orbitals, right? 2 s orbitals. That's a sigma bond. What we are shading there is the area of electron density, right? An orbital is a region of space around the nucleus where there is a greatest probability of finding an electron. So where they overlap, that's where the electron density is found. Next, sigma bond formed by the head-on overlap of 2 p orbitals. 2 p orbitals. Like that. Right? This is the area of electron density. That is also how a sigma bond is formed. Next, sigma bond formed by the head-on overlap of a p and an s orbital. Right? That's also a sigma bond. The head-on overlap of a p and an s orbital. Next, sigma bond formed by the head-on overlap of a hybrid orbital with an s orbital. A hybrid orbital, right? This is a hybrid. This is a hybrid orbital. Hybrid. A hybrid orbital. For example, we can call it bond. Any hybrid orbital. Hybrid, right? With an s orbital. Or the head-on overlap of a hybrid orbital. A hybrid orbital with a p orbital will also produce a sigma bond, right? A sigma bond. This is also another hybrid orbital. Yes. So there we have 1, 2, 3, 4, 5, right? Sigma bonds are formed by those methods. Now, pi bond formation. Pi bond formation has only one method, and that is the lateral overlap. The lateral overlapping. The lateral overlap of atomic orbital. Right, those are two pi bonds, right, that come together, two p orbitals. Sorry, the lateral overlap of two p orbitals. So all these ones are different types of sigma bonds, while here is a pi bond. Okay, now we are going to give the reasons why sigma bonds, or we are going to explain which of the two bonds are stronger. So bond strength, right? Bond strength, or sigma and pi bond strength. The strength of a covalent bond depends on the degree or the extent of overlapping. What did I say? The strength of a covalent bond depends on what? The extent of overlapping of atomic orbitals. The degree at which atomic orbitals overlap determines the strength of a covalent bond. If orbitals overlap so much, right, then they form a strong bond. If orbitals overlap just a little, then they do what? They form a weak bond. So the strength of a covalent bond is determined by the degree of overlapping of orbitals. Now, here we have sigma bonds and we have pi bonds, right? Sigma bonds and pi bonds. Now, what do you notice? You notice that when something, now let's go this way. If you observe here, you may be tempted to say that we have two levels of overlapping, right? And so a pi bond is stronger. Now let's see how they overlap. Here we have what? We have head-on overlap for sigma bond, and here we have lateral. When some things come together head-on and others come together laterally, which of them do you think will form a greater degree of fusion? Because here actually we have fusion of orbitals. When two things fuse head-on and others fuse like this, you just bend like this and I also bend like that. Of course, the one that comes head-on will fuse more, right? The one that comes head-on will fuse more than the one that just bend like this and the head is just right. So automatically, it therefore means that there is greater degree of overlapping in sigma bond than in pi bond. The head-on overlapping of orbitals in sigma bond brings about or results into what? So the head-on overlapping of orbitals in sigma bond formation results in what? A greater degree of overlapping. And as a result, a much loss in energy. Because take care, bond formation is exothermic, right? Here we are seeing how bonds are formed. Bond formation is exothermic, while bond breaking is endothermic. To break a bond, you need energy, while to form a bond, energy will be lost. So the head-on overlapping of orbitals in sigma bond formation results to a greater or a large extent of overlapping, which results to a great loss in energy and gives what? And gives a sigma bond a very high strength or a very large strength. So sigma bonds are very strong. Secondly, The lateral, just bend like that, just bend, you just touch a bit, right? The lateral overlapping of p orbitals in pi bond formation generates a low it generates a what? A low degree of overlapping or a low extent of overlapping. This results to what? This results to a minimum or a low loss in energy, right? Bond formation is exothermic. So the lateral overlapping of p orbitals in pi bond formation results to a low level of overlapping and a low loss in energy, giving the pi bond a weaker strength. So first point, sigma bonds are stronger than pi bond. First reason, because in sigma bond formation, there is greater degree of overlapping and large loss in energy. While in pi bond, there is what? There is low degree of overlapping and as a result, a low loss in energy, giving the pi bond a weaker strength. The second reason why sigma bonds are stronger is this. When you observe here, what do you notice? As I said, this ring, right, is the nucleus of the orbital, right? So when you observe here, what do you notice? You notice that the electron density, right, the electron density, this area, the electron density, right, electrons are found between what? Between the two nuclei of the orbitals. Electrons are found, right, in sigma bond formation. There are electrons between the two nuclei of the orbitals. Here, electrons between them, electrons between them, electrons between them. And as a result, there is no internuclear repulsion. We call it internuclear repulsion. So, in sigma bond formation, the presence of electrons between the nuclei of the orbitals eliminates internuclear repulsion. An absence of internuclear repulsion gives the sigma bond a high strength, right? A high strength and a high stability. In pi bond, electrons are not present, the absence. So here you have what? The two nuclei are free, right? They are free. They are what? They are close. They don't have any electrons between them. They don't have any disturbance, any obstruction between them because the electron density are displaced. So here, electrons are what? They are axial. This is axial overlapping. This is what? Displaced. So in pi bond formation, the absence of electrons between the nuclei of the orbitals brings about internuclear repulsion. So here there is internuclear repulsion. The two nuclei are positive and as a result they will repel. The two nuclei here will be repelling because what? There is free space. There are not electrons between them. And as a result, because of the repulsion, the pi bond will be what? Will be unstable. The pi bond will be unstable, and that instability of the pi bond will make the pi bond to be what? To be weak. So that's the second reason why sigma bonds are stronger than pi bond. Presence of electrons between orbitals in sigma bond formation minimizes, right, or reduces internuclear repulsion and gives a sigma bond stability and a high strength. Absence of electron between nuclei of atomic orbitals of p orbitals, right? You specify here it is p orbitals of between absence of electrons between nuclei of p orbitals in pi bond formation gives the pi bond brings about internuclear repulsion in the pi bond, and this gives a pi bond less stability and a weak strength. So that is the end of this session, right, where we have discussed about the strength of sigma and pi bonds. I hope you had a great understanding. Please like the video, share the video, and tell your friends about the educational biome of Pure Excellence, PDV LEADEX Education. Thank you so much for being there and see you in the next session. Bye-bye.